Okay, we have a screenshot of the 11 items will be on the final exam questions, and we also have other items which already in your practice quiz, and the 11 item I'm going through one by one. Okay, and the first one to upper, and sorry, it's to upper. So what is ASCII to upper? And the question is whether we have the understanding of ASCII table. When you go into upper cases, lowercase and uppercase is 20 hex difference. So let me show you the ASCII table. And this is the ASCII table we are talking about. The uppercase is 41 hex to 50Z, 50A hex. And what you do is 61 move to 41 hex. This way is to upper. And so actually lower 20 hex. So what you do is minus 20 hex number for if it is uppercase. So what you do here is if it is a lowercase 61 hex to 78 right here, 78 hex, if in this range you convert that to uppercase, which is 41 through 50A, 50A right here, x, and by that equation, it will be what I have here is to upper. Okay, that's the first one. Multiple questions, maybe one only. Next one, size T. I know, in fact, we have several questions. So size T is explained right here. And it's you go to C++ reference menu, and it has very brief description. So it basically is define the storage, how many byte in the how many byte you have allocated for. Again, the keyword is the type returned by the size of operator and is winding used in the standard library. So you can use this to get the size of allocation. That's the second one. And third one is ascending versus descending, and which I didn't write here is before and I'm sorry, not the inner loop and outer loop. And outer loop. Outer loop. So it's relevant to where you place your in the inner loop or outer loop. That, for example, you place in descending, that means you starting from right to left or left to right in the inner loop versus outer loop, it could be different. And the type of question, there are many, and depending on the loops. So this one is talking about loops and oops, okay. So if you understand it's gradually lower or gradually higher, that's the key of the problem here. And fourth one, we are talking about the array addressing and array and addressing. So the first one is zeros, and second one is ones, and the third one is second. and 0, 1, 2, 3, 4, and 5 is 6, 1. It has to be a 0 base when on the inside, and the iteration you use the same way. When the computer coding, it is called iteration, and when you have an array, you have the two-dimensional array, then you have the second iteration, third iteration, and so on. So you have to understand the iteration to understand two-dimensional array. Okay, this is can be tricky, so do your exercise. And swap function, number 5. Swap function. And you cannot do a direct swap. Each time only involve two parties. When you have 3 parties and you do a swap, you have to do 3 commands, like A equals to B, and B you place in temp, and then temp equals to A. So so you have to have the third party for a temporary placement. That's the swap. Look it up. We have plenty of illustration about how to make a swap. And 6 you have to pay attention to is the array. What you do is L value. I'm sorry. There are plenty of L value and R value issues, both in array and normal cases. In both cases, you have the data on which is L value are shown on the when you can show the L value, and you cannot show the R value. R value is just in the statement, and on the right side of statement you have the R value, and so that's an expression only, and it's not visible to the user, which you have to go through the I/O interface, and so we have to use statement to do it. That's on the left side. That's L value, and so you have to be careful. The expression is talking about L value or R value. Okay, so something that you need to know. And function is tricky, not exactly the same as in the case we have here. And to use the function, you have to be declared and defined. And in normal case, you can place the declare only and then define it later after main. But in most cases, if the function is small, you typically have the declaration and the definition at the same place, all beforehand. So it is allowed in programming that you do declaration and do the declaration later. And that's typically how it's done. Okay, next one, array of struct or struct of array. What's the difference? You have to know that. And how you address in the array. Because I said the zeros offset is first item in the array. And also in the struct, it's the same way. And you have to be able to know the difference between array and the struct. Okay, then we have some enums. There are several iterations, and what you need to know is to go to here, enum, and we have plenty of place to say enum. Let's go here, right here, enum. And okay, So the first one is number 2, Enum, chapter 11. Hello. And most enums enumerated data type. And let me blow it up. These are all the matches, and you have to go to chapter 11. That's the most enum cases, and the enum is quite abstract, and we talked a lot about the enum 2 and 12. Too long. Let's go here. I think it's here. No, I'm sorry. 11. Chapter 11. Sorry, wrong chapter. Here. My mistake. And it's on 11:12. So something about enum here that you have to pay attention to. And enumerated data types. That's what it is. And plenty of example right here in chapter 11:12. And you have to pay attention to. I'm not to verbosely go over this again. So if you have any question about enum, what is enum, go look at 11:12. Okay, next one. I did here. Okay. So I did the enum and Fibonacci. Let's see. That should be in the chapter 19. Oh, oh I have spelling issue. Recursion. Let's look at that. We're not TC. We're not. We don't have problem in this and Fibonacci. Okay, so right here, this is Fibonacci, and this is a sequence, and you can tell the number. So it is Fibonacci 0 is defined as 0, and Fibonacci 1 is defined as 1, and Fibonacci 2 is 1, Fibonacci 2, 1, and plus Fibonacci 0, which is 1, and Fibonacci 3 is 2, Fibonacci 4 is 3. So by a recursion here, this one, and you know the number and how it's written. It's written is the Fibonacci is called in Fibonacci. It's kind of funny, but you have to be able to write in recursion. You have to be able to write recursion. Okay, so we have covered Fibonacci, and some of the problem is struct, and struct is chapter 11. And it's quite important for this semester. So we will have some fundamental question about the struct right here. This is struct. And the entire chapter 11 is talking about struct. There are some questions associated with this. this section, and so you need to know this inside out. Thank you very much, and I will come to the conclusion of final review. Half of the question are the problems, half of the question are what I mentioned in the top items here. So good luck.